So today we're going to look at scale, and scale is topic 11 of the level 1 level 2 course. I'd like you to take a wee second just to think about maybe examples of where we would see scale used in real life. So what are scale drawings? Well, scale drawings are everywhere, and in my previous slide I asked you to think about maybe where you use scale, so hopefully you'll maybe be agreeing with what I'm putting up here in the slide. So we see it on maps, where possibly Google Maps you might have used, and even on your phone, street maps, that is all scaled, okay? Scale drawings, where you've got a real life object and it's scaled down to fit on a piece of paper. People will also use scale drawings to design vehicles, and obviously the most common one probably is house plans. So scale drawings then basically allow us to draw large objects on a smaller scale while keeping them accurate. They differ from sketch plans because sketch plans are just sketches of objects. They're not actually drawn to any accurate scale. All scale drawings must have a written scale on them, and scales are usually expressed as ratios, and you remember this from our ratio topic. So this is an example of a ratio scale, and it says 1 to 100. Can you take a second just to think what exactly that means? Okay, so the ratio 1 to 100 means that for every 1 centimetre on the scale drawn, the length will be 100 centimetres in real life. So whenever you're given a scale like this one, your units will always be in centimetres, even though it might be asking you to give your final answer in metres or kilometres. This scale is always represented in centimetres. The reason being is because you're actually measuring in centimetres. So you can see here this scale is 1 centimetre equals 2 metres, and this is quite more straightforward because obviously it gives you units automatically in the scale. This means that for every centimetre measured on the drawing, it represents 2 metres in real life. Therefore 2 centimetres on the drawing would represent 4 metres in real life, and so on. So here we have a TV, and you can see there that the height of the TV is 2 centimetres on the scale drawing, and the width of the TV is 4 centimetres wide. The scale of this drawing is 1 centimetre on the plan, represents 25 centimetres in real life. Can I ask you then to try to work out the actual width and height of the TV for me? And I'm going to give you a wee minute to do that. Okay, so if you hopefully have used the correct method, what we would actually be doing is, because the width of the TV is 4 centimetres, if I times 4 centimetres by 25 centimetres on the scale, this actually then would represent 100 centimetres in real life. So the actual width of the TV is 100 centimetres. The height of the TV then, which is 2 centimetres, if I times that by 25 centimetres on the scale, that shows me that the height of the TV is actually 50 centimetres in real life. And hopefully everybody was able to work that out okay. This is a question that has a scale plan of a dining room, and you can see there the scale plan measurements, and then the scale that we've been given in the question is 1 to 50. The question's asking us to find the length and width of the walls for the dining room and calculate its area. I'm going to give you a minute to think about what actually that scale means, and then how would you actually go about working out the real life measurements of the dining room. So hopefully from looking at the scale you will have recognised that on the left hand side we have the plan measurements, and on the right hand side we have the real life measurements. Okay. For this particular scale, because there's no units given, that means it's in centimetres, and for every centimetre on the plan it represents 50 centimetres in real life. If I wanted to find the real life measurement of the dining room in terms of the 6 centimetres, what does that represent in real life? Well, I know from this scale it's 50 times bigger in real life, so all I do is multiply 6 centimetres by 50. I should get an answer then of 300 centimetres, which is the actual length of the dining room in real life. To find the width of the dining room, I do the same thing. I times it by 50 because it's 50 times bigger in the scale. And then I should get an answer then of 225 centimetres in real life. So there are my length and my width of my dining room in real life. And to find the area, remember area is length times width. And all I do then is once I've got the real life measurements, I will times them to get a final answer. And the final answer is 67,500 centimetres squared. And remember please to put in your units in your answer, because obviously OCM may leave that bit blank and it's worth 1 mark. Now in some questions it can be a wee bit more trickier and they might ask you to give your answer in metres. And in that scenario, because you've got a scale here, this scale will always be centimetres. And what you need to be doing then is, because you've converted to real life centimetres, all you have to do is basically convert centimetres to metres by dividing by 100. And the little diagram that I explained to you about maybe writing it or drawing it out in the front of your exam at some point before you start answering any of the questions would really help you with your conversions and making sure you're dividing by the right thing. But if you divide that by 100, we get 3 metres. And if we divide 225 centimetres by 100, we get 2.25 metres. To work out the area then, once we've changed our conversions to the units we want and in real life, then we can work out the area by times and the length by the width. And we get an answer then of 6.75 metres squared. Now this is an example of a question that's similar to your topic workbook. And we have here a map and we're trying to find how far in real life is it between town A and town B. And you can see there that the scale is for every centimetre. It represents 75,000 centimetres in real life. So all we do is we firstly measure using a ruler the distance between A and B. And I would recommend that you pick the centre point whenever you're, this here wee point, the middle bit of the little X, or the middle bit of a circle to get the right, more accurate measurement. And whenever I measured that, I got 6.5 centimetres, okay, and that's just on the scale plan. So then what I do is I will multiply the 6.5 centimetres by the scale of 75,000 because it's 75,000 centimetres bigger in real life. So whenever I do that, I get a real life measurement then, a real life distance between the both towns of 487,500 centimetres. Now, if the question asked you to give your answer in kilometres, hopefully everybody would be confident now to do that. But basically what you'd be doing is using your little diagram that you would draw at the start of your exam, and that would help you with your conversions. And in this scenario, what we'll be doing is changing centimetres to metres first, and then metres to kilometres. So centimetres to metres we will divide by 100, and then metres to kilometres we're going to divide by 1,000. And you can see there my working out for this. So it's 487,500 centimetres divided by 100, I get 4,875 metres, and then if I divide that by 1,000, I will get 4.875 kilometres in real life. Okay, so make sure that you do your real life conversions first and then convert to whatever units you need to give in your answer. Okay, so now we have a scale plan of a pond, and the question's asking us to work out the following in metres. We have to work out the length, the width, the perimeter and the area. It's given a scale of 1 to 75, and if we think carefully what exactly that scale means first of all. So remember that the left hand side of the scale is the plan, and on the right hand side it shows the real life measurements. So for every centimetre on the plan, it represents 75 centimetres in real life. To do this question, I'm going to need my diagram for conversions, okay, and then I'm going to need my ruler to measure the length and width of the pond. So I'm going to measure the length, 8 centimetres, and I'm going to work out this to real life. So I'm going to go 8 times 75, which is this part of the scale. Remember, it's scale to real life, we always multiply, and we get 600 centimetres in real life. Then I'm going to measure the width. The width is 6. If I times that by 75, that will tell me what it is in real life. So the real life width would be 450 centimetres. To give this answer now in metres, what I'm going to need to do is convert centimetres to metres. And centimetres to metres, I divide by 100. So I've got 600 centimetres, which equates to 6 metres in real life. Width-wise, I do the same. I divide by 100 and I get 4.5 metres in real life. To find the perimeter of the pond, I'm using real life measurements only. And the perimeter, remember, it's adding all sides. So I'm going to add up my length, which is 6 plus 4.5 plus another 6 plus 4.5, and I should get 21 metres then. Remember to put your units in at the end. To work out the area is length times width, and again only use the real life measurements and the units that it wants you to give in your answer. So here we have a length of 6 metres and a width of 4.5, and I'm going to times them to get 27 metres squared. And again, remember to put your metres squared in your answer. These things normally aren't given, so just remember that whenever you're giving your answers, put in your units at the end. Okay.